The first aluminum foil was produced in 1903, and in 1911 it was used as packaging for Toblerone chocolate bars from Switzerland. Thanks to this, the chocolates were kept longer and could be sent further. Nowadays, around 5 million tons of aluminum foil are used worldwide every year. But have you ever wondered how it's made? Pure aluminum is obtained by refining bauxite, a mineral rich in aluminum oxides. Bauxite is mined from open pits or underground mines and undergoes a chemical process called bayerization. The bauxite is crushed and mixed with sodium hydroxide, dissolving the aluminum components and separating other minerals as solid waste. The resulting solution is filtered and purified to obtain pure alumina, a chemical compound of aluminum oxide. The alumina is then put through an electrolysis process, where it is dissolved in an electrolytic bath and subjected to a strong electrical current. This separates the pure aluminum from the alumina, depositing it on the cathode of the system. Pure aluminum is collected and cast into ingots or blocks known as billets. Subsequently, the pure aluminum billets undergo a meticulous rolling process to obtain thin and flexible sheets, essential characteristics of aluminum foil. Once the aluminum billets are obtained, they're subjected to high temperatures to increase their malleability. Then, through hot rolling, they are passed through rollers that apply controlled pressure, gradually reducing their thickness and obtaining thinner and more uniform sheets. Subsequently, cold rolling is carried out, where the sheets are cooled and again subjected to rollers to refine their thickness and achieve a smooth and shiny surface. Precision rolling is crucial in aluminum foil manufacturing, as it determines its quality and performance. Each process stage is carefully monitored, from temperature control to the pressure applied by the rollers, to ensure that the sheets meet established standards. This process ensures that the aluminum foil has the strength to withstand extreme conditions without compromising its structural integrity. Cold rolling reduces the thickness of aluminum and improves its surface finish, removing blemishes and providing a smooth, shiny surface characteristic of aluminum foil. In addition, it gives the sheets more resistance and flexibility, facilitating their handling and use in various applications. To prevent oxidation and adhesion, an aluminum oxide coating is applied that acts as a barrier against corrosion, guaranteeing the integrity of the aluminum foil during its useful life. In addition to coating, special lubricants are applied that make aluminum easier to handle and manipulate during manufacturing. These lubricants reduce the friction between the blades and the rollers, ensuring smooth and uniform sliding and avoiding unwanted deformations. These protective layers and special lubricants guarantee the product's flexibility, manageability, and resistance, allowing its application in various industries, from food packaging to the manufacturer of industrial components. At this point, the coated and lubricated aluminum sheets are finally transformed into the aluminum foil we all know, with its distinctive shine and characteristic flexibility. A series of special rollers are used to stretch and thin the aluminum sheets in a controlled manner, applying pressure and tension. In manufacturing aluminum foil, precise cutting, packing, and distribution are the last stages before reaching the final customer. After obtaining the aluminum foil coils, a precise cut is made to obtain rolls of specific dimensions, avoiding waste and optimizing their use. These packaged rolls are placed in high-quality boxes or containers for distribution. Aluminum foil packaging is done considering both the visual presentation and the protection of the product. An attractive and quality packaging is sought that transmits confidence in the aluminum foil, in addition to implementing security measures to guarantee that it arrives in optimal conditions at the final destination. The distribution of aluminum foil is carried out through different channels, such as supermarkets, kitchen supply stores, and industrial suppliers, satisfying customers' needs locally and internationally. The earliest use of glue can be attributed to the Neanderthals, who made it from animal parts. Although the raw materials used today are not much different from the past, the process has become much more streamlined to cater to global demand. It's estimated that the average American uses 18.2 kilograms of glue per year. So how did they do it? Animal glue is primarily made from collagen, a protein found in the connective tissues and bones of animals. The most common source is animal hides, such as cattle or horses. But bones, tendons, and other parts can also be used. These raw materials can be obtained from a variety of sources, such as farms, tanneries, and meatpacking companies. It is no coincidence that the world's largest glue manufacturer is the dairy company Borden Company. For fish glue, the raw materials include the bones, scales, heads, and skins of fish. These are obtained from canneries and other processing plants. Although the raw materials for animal and fish glue are different, the process for making both types of glue remains largely the same, only with minor variations between the two. Once the raw materials are procured by the factories, they are prepared for the process ahead. The hides and other animal remains are washed so that dirt or other impurities can be removed. They are then submerged in water to soften the material. This softened animal material is called stock, and it is passed through a series of water baths in which more and more lime is added to make the hides and skins swell and break them down into collagen. The swollen hides are then rinsed in a large washing machine to remove the lime. However, trace quantities of lime still remain. The last traces of lime are eliminated by treating the stock with weak acids like acidic or hydrochloric acid. This process is called neutralization and was discovered by chemists in the 19th century. Once the lime has been completely removed, the stock is cooked either by boiling it in open tanks or cooking it under pressure in autoclaves. Cooking at the correct temperature and for the right length of time breaks down the collagen and converts it into gelatin or glue. If the temperature or timing is off, the quality of the glue will be ruined. Large steam coils in the open tanks heat the water and product to 160 degrees Fahrenheit, 70 degrees Celsius. 3 or 4 treatments with clean water are performed at increasing temperatures. The resulting liquid, called glue liquor, is extracted and reheated again to thicken the glue. When cooled, the glue resembles a jelly-like substance, but still has a lot of impurities that need to be removed, either chemically or mechanically. For the chemical removal of impurities, alum or acid followed by egg albumin may be added. The subsequent reaction causes the impurities to precipitate out of the glue, leaving pure glue behind. Once the impurities have been removed from the glue liquor, it can be used to make a variety of adhesives. Sulfuric acid, phosphoric acid, or alum may be added to make brown, clear, or white glue. For white school glue, zinc oxide is added to the glue liquor. At this point, the glue is a weak, runny liquid. Its concentration is increased by placing it in vacuum evaporators and drying via several methods. The glue can be chilled into either sheets or blocks and then suspended on nets to dry and become even more concentrated. After that, these are poured into different tubes, containers, and sticks for commercial use. Rather than perform a quality check at the end, glue manufacturers carefully monitor each bit of the process. This is because the temperature and pressure required to make glue must be very precise. Otherwise, large quantities of stock will be wasted. There's also the concern about safety and sanitation. Since the main raw material used for making glue is animal or fish parts, it's easy for them to get contaminated. To prevent this and other problems such as disease, vermin, and cost of transportation, glue factories are located very close to the supply of raw materials. The applications of glue have come a long way from the days of our ancestors. Experts predict that glues will replace more and more forms of fastening over the next few years, to the point that even wounds may be fastened by glue. If you like this video and want to see more like it, check out this other video.
With Flex Glue, you can do them all.